Hello and welcome back to Engineers Olympiad, where learning meets success. We're on to the first chapter of bridge engineering, that is fundamentals and basic concepts of it. And we have completed the video lecture number 1, wherein we discussed what is a bridge and what are its components and the role of each and every component. All right, so this is the video lecture number 2. In case you've missed the video lecture number 1, you can watch that on channel. That's already up on the channel Engineers Olympiad. So let's begin. Basic forms of bridge. In video number 1, we discussed about what is a bridge. Bridge is essentially a structure which provides a passage or an obstacle, but without closing the way beneath. And now we are going to study various forms of bridge. There are various classifications of bridges which we are going to study later, but there are 7 basic forms of bridge, which is essentially a classification based on the type of the superstructure. Superstructure is that part of a bridge which is above the level of bearings. That part of the bridge which is below the level of the bed, level of the river, or which that particular bridge is made. The part which is below the level of the bed level of the river is known as the foundation. The part from the bed level to the bearings is known as the substructure, and that component or that portion of a particular bridge which lies above the level of the bearings is known as the superstructure. That we have already discussed in video lecture number 1, and we are going to study about the basic forms of bridge, which is essentially a classification based on the type of the superstructure. But classification on other types, on other criteria, we're going to study later. But today's video lecture is about the 7 basic forms of bridges. So we have 7 basic forms of bridges. The first one is a beam bridge. The second one is a truss bridge. Third one is arch bridge. We have cantilever bridge. The fifth one, suspension bridge. We have cable stayed bridge as well. Cable stayed bridge. And the 7th one, or the last one, is a tied arch bridge, which is also known as a bowstring bridge. Tied arch bridge, or also known as bow and string bridge. Okay, so we have essentially 7 basic forms of bridges. We have beam bridge, truss bridge, arch bridge, cantilever bridge, suspension bridge, cable stayed bridge, tied arch bridge, or a bowstring bridge. All right, so we're going to study each and every one of them one by one. So let's start with the beam bridge first. These are 7 basic forms of the bridge types, essentially a classification based on the type of the superstructure used. So let's study them one by one. First, we have a beam bridge. All right. This is also known as a girder bridge. So we can write it as a beam bridge or a girder bridge. All right. So this beam bridge or a girder bridge is the simplest type of bridge. And what do we need? In the most basic form, all that we need for making a beam or a girder bridge is that we need to cover the span with the help of a cross beam. A cross beam that is long enough to cover the span between the two abutments. Between two abutments. Okay. So a beam bridge or a girder bridge is the simplest type of bridge, and all that we need is a cross beam that is long enough to cover the span, and that will be essentially supported by the two abutments on each end. All right. So a cross beam that is long enough to cover the span is essentially that is needed to form a beam bridge. And who will give the support? The abutments from under each end will provide the support to that cross beam that is long enough to cover the span to form the basic type of a bridge, which is known as a beam bridge or a girder bridge. However, let me drop it first. To achieve longer spans, which are over 80 meters in length, to achieve more longer spans which are greater than 80 meters in length, you need to add piers or pairs, howsoever you may like to pronounce them, so that they may provide extra support. So to achieve a longer continuous span over 80 meters, all that you need is that you need to add pairs to provide the extra support. That means when you're going to do this, you're creating a series of bridges that are joined together. Let me show you how. This is one abutment. This is another abutment. This is for a long span or 80 meters in length. You need a cross beam or parallel beams that will support the deck. All right. And if this span is above 80 meters, you need to add piers. And they will provide you the extra support. Span we have already discussed in video lecture number 1. The span is the center to center distance between the two adjacent piers or abutments or the supports in a bridge. All right. So by doing this, by adding piers, when my span exceeds 80 meters, I'm essentially creating a series of bridges which are joined together. All right. So I'm creating a series of bridges which are joined together, and this forms my beam bridge or a girder bridge. And this structure is often termed as a simply supported structure. Simply supported structure. So in simpler terms, a beam bridge is a horizontal deck which is supported by two beams between abutments or piers, and this deck is positioned across the beams and it creates a simply supported structure. All right. These beam bridges or girder bridges can be made of wood, concrete or steel. That must be known. They can be made of wood, concrete or even steel. All right. And unlike more complex bridge designs, these beam bridges or girder bridges directly support the loads through beams. These support loads directly through the beams without transferring the stresses through arches or cables, which we are going to learn about other bridge forms, wherein they transfer the stresses via arches or cables. That is not being done in case of a beam bridge or a girder bridge, where the loads are directly transferred through beams. So in a beam bridge or a girder bridge, it supports loads directly through beams without transferring the stresses through arches or cables, unlike other bridge forms. All right. And you must also note that this, in case of a beam bridge or a girder bridge, the loads are carried by flexure, which is known as bending. So the loads in case of a beam bridge or a girder bridge are, the loads are carried by flexure. And flexure means flexure bending. All right. So the loads are carried in a beam bridge by flexure. And these beam bridges or girder bridges are relatively very feasible for short spans. It must be known. All right. So a beam bridge or a girder bridge is that type of bridge in which its simple cross beam is needed to support the loads, and support for the cross beam is in turn provided by the two abutments or piers. All right. And to create longer spans above 80 meters, we need to add piers so that it can provide extra support. And by doing this, we are creating essentially a series of bridges that are joined together. And this structure is known as a simply supported structure in which the deck is supported by two beams that are running parallel between the abutments, and the deck is positioned across these beams. And this beam bridge or a girder bridge is the simplest type of the bridge, and it is used for short spans, and the loads in case of a beam bridge or a girder bridge are carried by flexure or bending. Vertical loads are carried by flexure or bending in case of a beam bridge. And these beam bridges can be made of wood, concrete, or steel. Now let's study about advantages and disadvantages of the beam bridges. Let me rub it first. All right, advantages. The various advantages of beam bridges. The first one being that they are cost effective. These beam bridges or girder bridges are cost effective. That means they are generally cheaper to construct compared to more complex bridge designs like arch or suspension bridges. All right, so these beam bridges or girder bridges are cost effective. That is their first and foremost advantage, and they are generally cheaper to construct and maintain. Unlike arch bridges or suspension bridges, which we are going to study later, arch bridges or suspension bridges. This is the advantage number one, that they are cost effective and they are cheaper to construct and maintain, unlike arch bridges or suspension bridges. Advantage number two, they are inexpensive if no piers need to be added. If no piers need to be added, if the span is shorter, less than 80 meters, and no piers need to be added to provide that extra support, these beam bridges or girder bridges are inexpensive. The advantage number three is that modules can be prefabricated away from the bridge location. The site where we are going to construct the bridge, this beam bridge or the girder bridge, we can prefabricate the modules away from the bridge site or the location, and then we can install them there. All right, so this is the advantage number four. Third, that modules can be prefabricated away from the bridge location. Away from the bridge location. Let us study about advantage number four, but before that I'll rub it. So the first advantage of a beam bridge or a girder bridge is that it's quite cost effective. That is, it's easy to construct and rather cheaper to construct and maintain, unlike arch bridges or a suspension bridge. Second advantage, that it's quite inexpensive if no piers need to be added, if we are going to construct them for the shorter spans. And the third one was that modules can be prefabricated away from the bridge location. Now the fourth advantage of this girder bridges is that they are versatile and they can be used in many locations like highways, railways, or even pedestrian paths. So they are versatile and can be used in many locations like railways, highways, or pedestrian paths. Railways, highways, or even pedestrian paths. All right, so this is the advantage number four of a girder bridge. The fifth one is that multiple types of materials can be used. That was already discussed, that they can be made out of wood, concrete, or even steel. Multiple types of material can be used. So this was about the beam bridge and their advantages. Now let's study disadvantages. The disadvantages of a beam or a girder bridge are, the first one being that limited span between supporting structures can be created. Limited span length between supporting structures. Limited span length between the supporting structures. So that means these beam bridges or girder bridges are not ideal for long spans. All right, so they are not ideal for the long spans, and they tend to be weaker as the span gets increased. As the span increases, they tend to get weaker. So this is the first disadvantage of a beam or a girder bridge, that limited span length between supported structures can be made out of these bridges, and when the span gets longer, they tend to become weaker. Let's study about disadvantage number second. The second one is that they start to sag as they age. They start to sag as they age. That means they can experience bending or deformation under heavy loads. Bending or deformation under heavy loads. Okay? These beam bridges or girder bridges start to sag as they age, and they experience bending or deformation under heavy loads. This is the disadvantage number second. The third one is that they have poor aesthetics. Unlike other bridge forms, which are more beautiful and pleasing to the eye, these beam bridges or the girder bridges are the simplest type of bridges, but they present poor aesthetics. So this was about the advantages, disadvantages, and the basic definitions and illustrations of a beam bridge or a girder bridge. And this is the first basic form of a bridge. We have 7 types. We have studied first one, that is beam or a girder bridge. Moving on, let's study second one, that is a truss bridge. Truss bridge. What is a truss? A truss is a structure of connected elements to form triangular units. You all know that truss is a structure of connected elements to form a triangular units. Okay, so a truss is a structure of connected elements to form triangular units, and the bridge deck in case of a truss bridge is supported by steel trusses. So bridge deck in case of beam bridge was supported by cross beams or girders, but in case of a truss bridge, the bridge deck is supported by means of steel trusses. And what is a truss? A truss is a structure of connected elements to form triangular sections or units, which are known as trusses. All right, and the bridge deck in case of a truss bridge is supported by steel trusses. So these truss bridges, they incorporate triangular sections, which are known as trusses, to create a structure which is capable of handling dynamic loads. So the truss bridges in which this Bridge deck is essentially supported by means of steel trusses. They incorporate these triangular sections, which are known as trusses, to create a structure which is capable of handling dynamic loads. And these trusses, they absorb both tension and compression. You must know that. They have the capability of absorbing both tension as well as compression. They can absorb both tension and compression. These truss bridges are renowned for their sturdy framework. They're renowned for their sturdy framework, which is made of interconnected triangles known as trusses. And this geometric design provides them exceptional strength. This provides them exceptional strength, and thus they make them useful or ideal for both road as well as rail crossings. All right, so a truss bridge is a bridge in which the deck is supported by means of steel trusses, and these triangular units or trusses, this geometry gives them exceptional strength, and they are capable for absorbing both tension and compression, and they are ideal for both road as well as rail crossings. All right, and this truss bridge of simple span, it behaves like a beam. A truss bridge of a simple span behaves like a beam because it carries vertical loads by bending. Same in case of a beam bridge or a girder bridge, wherein vertical loads are carried by flexure or bending. In the same way, this truss bridge of simple span behaves like a beam because it carries vertical loads by bending. The top chords in case of a truss bridge are in compression, bottom chords are in tension, whereas vertical or diagonal members, they can be in tension or compression. That depends upon their orientation. All right, so here in the diagram you can see this is a truss bridge wherein we have incorporated the triangular units or the steel trusses to support the bridge deck. All right, the top chords are in compression, the bottom chords of a truss are in tension, and these vertical or diagonal members, they can be either in tension or compression. That depends upon their orientation, and that's why I told you, we discussed earlier, that these truss bridges are capable of handling dynamic loads and they can absorb both tension and compression. That is why they are renowned for this study framework, and this geometry provides them exceptional strength. These truss bridges have been found around for centuries and are known for their efficient design, as already discussed, and you can find historic truss bridges can be found worldwide. All right, so this was about the truss bridge. Wherein top chords are in compression, the bottom chords are in tension, and the diagonal or the vertical members can be either in tension or compression. That depends upon their orientation. So this truss bridge, wherein the bridge deck is supported by means of steel trusses, which are the interconnected triangular sections, they provide them exceptional strength and they are capable of handling both compressive loads as well as tensile loads. That is, they are capable of handling dynamic loads, and they are renowned for their study framework and can be found worldwide. And this truss bridge of a simple span essentially behaves like a beam and carries vertical loads by bending or flexure. Now let's study about their advantages. The first one is that they are known for their ability to distribute loads efficiently. They distribute loads efficiently, and this triangular shape of trusses make them structurally stable. As already discussed, they are structurally stable because of their triangular shape, and they are capable of supporting heavy loads over long spans. They are capable of supporting heavy loads over long spans, supporting heavy loads over long spans. So this is the first advantage of a truss bridge, that because of their triangular shape, they are structurally stable and they are capable of supporting heavy loads over long spans, and they have very good ability to distribute loads efficiently. Let's go and study the next one. The second advantage of a truss bridge is that they can be built off-site and quickly installed at site. Okay, these truss bridges can be built off-site and then they can be quickly installed at site. Third advantage is that they are lighter than other bridge types. Lighter than other bridge types. Next one is that they can withstand extreme weather conditions. They can withstand extreme weather conditions. So these were the advantages, various advantages of a truss bridge. The first and foremost being that they distribute the loads efficiently. The triangular shape of the trusses give them exceptional strength and stability, and they are capable of handling heavy loads over long spans, and they can be built off-site and then can be quickly installed at site. They are lighter than other bridge types and they can withstand extreme weather conditions. Now let's study about their disadvantages. The first one is the aesthetic appeal. Some people find these truss bridges to be less visually appealing compared to more modern bridge designs. So this is the first disadvantage, that they don't have a good aesthetic appeal and many people don't find them visually appealing. And we have more beautiful bridge designs like the suspension bridge or a cable stayed bridge. They are more pleasing to the eye. So they have limited aesthetic appeal, which counts for the first disadvantage of the truss bridges. The second one being maintenance. Truss bridges, particularly those made of steel, can be prone to corrosion and they require regular maintenance, especially in environments with high humidity or salt exposure. All right, so these bridges, which are truss bridges, which are made of, particularly made of steel, they are very prone to corrosion and they require regular maintenance. Especially in the environments where there is high humidity or salt exposure. High humidity or salt exposure, in those environments, they are more vulnerable to corrosion, thus they require regular maintenance. This is the disadvantage of these steel truss bridges. Next one is weight. While they use less material than solid beam bridges, but the individual components of a truss bridge can still be heavy, and they require significant equipment for transport and assembly. We studied that they are lighter than other bridge types. Though they use less material than solid beam bridges, but the individual components of a truss bridge can still be heavy, so they require significant equipment for transport and assembly. Thus accounting for the disadvantage number third, that is weight, that they require significant equipment for transport and assembly. But still they use less material than the solid beam bridges or the girder bridges, but the individual components can be heavy, which require significant equipments for transport and assembly. This is the disadvantage number 3 of a truss bridge. Let's study the fourth one. Let me drop it first. Limited vertical clearance. They have limited vertical clearance. So these truss bridges have limited vertical clearance. What is a vertical clearance or a distance? It's the distance between the underneath of the bridge, that is the bridge deck, and the road or a river body below. That is in case of a road bridges or a river bridges. That means that is known as the vertical clearance or the vertical distance. Let me write it down over here. It is the distance that is measured from underneath the bridge deck to the surface below. In case of a road bridge, it will be the effective distance between the road and the underneath of the bridge deck. And in case of a river bridges, it is between the river HFL and the underneath of the bridge deck. All right. So the disadvantage number 4 of the truss bridges is that they have limited vertical clearance. Depending on the design, these truss bridges may not provide as much of a vertical clearance as other type of the bridges, which is a big drawback. Especially in those areas where there are high traffic or navigation requirements. High traffic in case of a road bridge and high navigation requirements in case of a river bridge. So the drawback number 4 of these truss bridges is that depending upon their design, they do not provide as much of a vertical clearance as other bridge types. So this accounts for their disadvantage or the drawback, especially in those areas where there are high traffic and navigation requirements. The last disadvantage that we are going to study here about the truss bridges is that complexity in design. Complexity in design. While being versatile, this design of a truss bridge can become quite complex when we are aiming to optimize for different loads and conditions. Their design can become quite complex when we are optimizing for different loads and conditions, and this can increase our engineering effort and the time required for planning and construction. All this can lead to increase in our engineering effort and the time required for planning and construction of these truss bridges. All right, so this was about the truss bridges. Moving on. So in case of a beam or a girder bridge, the deck is supported by the cross beams or the girders. And in case of a truss bridge, the bridge deck is supported by steel trusses, which are capable of handling dynamic loads, and they can absorb both tension and compression. And this geometric design of these connected triangular units or trusses give them exceptional strength and stability, thus making them more capable of handling heavy loads for more longer spans. Moving on, let's study about the third basic form of a bridge, that is known as the arch bridge. These arch bridges use one or more arches as the main structural component, with the arches positioned beneath the deck. All right. So in case of an arch bridge, arches are used as main structural component and these arches are positioned beneath the deck to support the deck of the bridge. All right, and this method of making arch bridges, this dates many thousands of years, with stone brick being the most commonly used material. All right, stones and bricks, these materials were used to construct these arch bridges, wherein they use one or more arches as the main structural component, and these arches are positioned beneath the deck to support the deck. But nowadays, these arch bridges, they are made of concrete. Earlier they were made out of stones and bricks, but nowadays they are made of concrete. Right? Loads in case of these arch bridges are carried primarily in compression. This must be noted that the loads in case of these arch bridges are carried primarily in compression by the arch bridge, with reactions at supports being both horizontal and vertical forces. So the loads in case of arch bridges are primarily carried by compression by the arch bridge, with reactions at the supports being both horizontal and vertical forces. That means the arch primarily carries loads through compression, and then it transfers these forces to the abutments or piers. Then these loads are transferred to the abutments or piers. The load in case of beam bridge or a girder bridge was carried by vertical loads were carried by bending or flexure. The same was the case in case of a truss bridge, but in case of a arch bridge, the loads are primarily in compression by the arch bridge, with the reactions at the supports being both horizontal and vertical forces, and then transferring these forces to the abutments or piers. All right. These arch bridges are characterized by their curved shape, and this curved shape allows efficient load distribution. curved shape of arches. This allows efficient load distribution. And this arch shape converts vertical forces into compressive forces along the arch ribs. I'll make a diagram and show you how. This is the arch, and this is the arch rib. This is the horizontal thrust. These are the vertical reactions. All right, this is the arch rib, and the arch rib is characterized by its curved shape, which allows efficient load distribution, as already discussed. And this arch shape converts the vertical forces into compressive forces. Vertical forces from the load from the deck, it's converted into compressive forces along arch rib. All right. So the vertical forces that come from the bridge deck, they are converted into compressive forces along the arch rib. This is the arch rib, the curved shape of the arch. All right. And this curved shape of the arch, this allows for the efficient load distribution. All right. And these arch bridges, they resist bending forces and have pressure resistant design. They resist bending forces and have pressure resistant designs. These arch bridges have a classic and enduring design, which is characterized by their graceful curved shape. All right, and these bridges rely on the natural strength of the arch to support the loads and thus make them ideal for spanning rivers and valleys. Let me write it down over here. The arch bridge is that type of a bridge wherein we use one or more arches to support the load from the deck, and they are positioned beneath the deck, and this curved shape of the arch allows efficient load distribution, and this arch shape converts the vertical forces into compressive forces along the arch ribs. All right, but the loads in case of an arch bridge are primarily carried in compression by the arch bridges, with the reactions at the supports being both horizontal and vertical. And this graceful curved design of these arch bridges make them ideal for spanning rivers and valleys, because they rely on the natural strength of the arch to support the loads. All right, so this was about the arch bridges. The Roman aqueducts and the Sydney Harbour bridges exemplify the timelessness and the efficacy of this bridge type, the arch bridge type. All right. If this is one of the abutment, this is another. Let me make it a longer one. All right. All right. It's essentially the basic form of a arch bridge, wherein one arch has been incorporated to support the vertical loads coming from the bridge deck. We can use multiple arches also in case of a longer spans. And this curved shape of the arch allows for efficient load distribution. And this graceful design make them classic and elegant, and natural shape of the arch gives them high strength, and they're ideal for spanning rivers and valleys, and the loads are carried primarily in compression. Vertical forces are converted into compressive forces along the arch ribs, and then they are transferred to the abutments or piers. All right. Now let's study about their advantages and disadvantages. Advantages first. All right. First one is the strength and durability. Strength and durability. The first advantage of the arch bridges is that arch bridges distribute the weight and forces effectively, making them highly durable and able to carry heavy loads. All right. They distribute loads effectively. That means they distribute the weights and the forces effectively, making them highly durable and able to support or carry heavy loads. Okay, so this is the first advantage of the arch bridges, that they have high strength and durability. The second one is aesthetic appeal. They are very beautiful and very pleasing to the eyes. The second advantage of these arch bridges is that they have good aesthetic appeal. Let me write it down over here for you. They have a classic and elegant appearance, and this makes often them a desirable choice in scenic or historic areas. In scenic or historic areas, we prefer arch bridges because they have classic and elegant appearance. The third advantage, material efficiency. This is the third advantage of these arch bridges, material efficiency. The design of the arches uses materials effectively by focusing on compressive forces. That means less material is often needed than other bridge types. These arch bridges use materials effectively by focusing on the compressive loads, meaning we require less material in case of arch bridges than other bridge types. Fourth advantage, they have a long lifespan. These arch bridges have a long lifespan due to their stability and ability to withstand environmental factors like water, wind, or temperature changes. All right, so these arch bridges have a long lifespan due to their stability and ability to withstand harsh environmental factors of water, wind, or even temperature changes. They can withstand all the effects of the environment. Thus, they have a longer lifespan. Next advantage is that resistance to compression. Resistance to compression. As already discussed, that this arch shape naturally resists bending and is highly effective in bearing weight, thus making it ideal for crossing wide valleys or rivers. All right. So these were about the advantages of the arch bridges. Now let's study about their disadvantages, because everything has its pros and cons. So have the arch bridges. Disadvantages. The first one is that their construction can be expensive. expensive construction. The design and construction of arch bridges can be costly, particularly for longer spans. Why so? Because of the need for specialized materials and labor. Specialized materials and labor. For longer spans, there is high need for specialized materials and labor, thus making their construction quite expensive. So this is the first disadvantage of an arch bridge, that their construction is expensive. The second disadvantage of these bridges is that they have a complex construction. First one was that they have expensive construction. Second one is that they have complex construction. Building an arch bridge can be technically challenging, often requiring precise alignment and significant groundwork. We require precise alignment and significant groundwork. That means building an arch bridge can be technically challenging, and hence their construction is quite complex. Limited span length is the next disadvantage of these bridges. Disadvantage number 3, limited span length. Limited span length. Arch bridges are generally more effective for medium spans. And can be limited in their ability to accommodate very long spans. They cannot accommodate very long spans, hence they have limited span length, which is their drawback or adds to their limitations or the disadvantages. Next one is the inclined reactions. Inclined reactions. The reactions in case of the arch bridges are inclined, thus it becomes very necessary that we have to provide heavier sections for the abutments and piers in case of arch bridges. Because of the inclined reactions, we have to necessarily provide the heavier sections for the abutments or piers in case of the arch bridges. And why do they have these inclined reactions? This is to resist the horizontal thrust, thus ensuring the stability of the arch. If the reactions would have been vertical, they would fail. That's why the reactions are inclined to resist the thrust of the arch shape. So this ensures the stability of the arches. Inclined reactions. And because of these inclined reactions, we have to design heavier sections for the abutments or piers, which adds to the drawback of these arch bridges. But these inclined reactions are necessary to support the horizontal thrust so that we can ensure the stability of these arch bridges. But because of these inclined reactions, we have to support the heavier. We have to rather design heavier sections for these abutments or piers that are to be used for the particular arch bridges. But designing a heavier section for the piers or abutments adds to the drawback of these arch bridges. And that is taken care of by the tied arch bridge or the bowstring bridge, which we are going to study later on. All right. Next limitation or the disadvantage is that rise. See, if I'll be making this diagram again. This is the abutment. This is the, let me make it a little, abutment. All right. This is the arch, and this is the bridge deck. All right. This is known as the rise of the arch. You must be familiar with this. The rise of the arch will have to be accommodated between, this is the formation level of the road, and this is the springing level of the arch. What do you mean by springing level of the arch? The starting point of the curve of arch, springing level. Let me make another diagram over here. This is the arch. These are known as the springing levels. Springing level is the starting point of the arch's curve. So this is the springing level, the starting point of curve of an arch. All right, that is known as the springing level. This is the formation level of the road, and this is known as the rise of the arch. All right, so how this is a limitation. See, this rise needs to be accommodated between the formation level of the road and the springing level of the arch. All right, in case of arch bridges, we have to accommodate the rise of the arch that we are designing for that particular arch bridge between the springing level of that particular arch and the formation level of the road, the approach road to which we need to connect this bridge. All right, so in those situations wherein this level of approach is low, where level of approach is low, these arch bridges become quite uneconomical. All right, in those particular situations where the level of the approach is low and we need to accommodate the rise of the arch between the springing level of the arch and the formation level of the road, those particular situations where the level of approach is low, these arch bridges become quite uneconomic, because it's quite evident that in any case we have to accommodate the rise of the arch between the springing level of the arch and the formation level of the road. All right, so this was another disadvantage of these particular bridges. The last one is aesthetic limitation, though they have quite good aesthetics, but in certain cases these aesthetics can be a limitation. This is the last disadvantage that we are going to study today about these arch bridges, that is the aesthetic limitation. While they are quite beautiful, they have very classic and enduring design, but this curve of an arch may not suit. All right, this cannot suit in every location, in any location. Thus, in highly urban or highly modernized settings where different bridge designs are preferred, we cannot prefer arch bridges over there. All right, you may find this quite contradictory. Since they have pleasant aesthetics, they are very good in scenic or historic areas, but while being quite beautiful, this distinct curve of an arch may not suit every location, especially that of a highly urban or highly modernized setting where different type of bridges are used, like suspension bridges, cable stayed bridges, or other type of bridges. So this adds to their disadvantage. Though being aesthetically very appealing, this can be a limitation at times. All right, so we have studied 3 bridge types today. We have the 7 basic forms of the bridges. We studied 3 today: the beam bridges or the girder bridges, wherein the bridge deck is supported by means of the cross beams or the girders and the loads are carried by flexure or bending. Then we studied about the truss bridges, wherein the bridge deck is supported by steel trusses or trusses, which are the interconnected triangular units, and this geometry provides them exceptional strength and stability. Then we studied about the arch bridges, wherein we incorporate arches beneath the deck to support the loads from the deck, and the vertical loads from the deck are converted into compressive forces along the arch ribs, and they have pressure resistant designs, and they can very effectively resist bending, and they can support heavier loads for even longer spans. The other types of bridge forms we'll study in the next video lectures or the upcoming video lectures. And thank you for watching this video.